Another epic winter in California.
Just awful last year, but this year it's a lot worse.
Powerful storms flood the Bay Area.
It's disheartening. I probably am homeless.
And prompting swift water rescues.
Unleashing strong winds, bringing down massive trees.
A very loud thump.
Leaving people without power, with some not even able to call for help.
No cell phone service and no landline. I can tell you how scary that is.
Huge waves batter the coastline, damaging businesses and sending people running for cover.
Look at my car.
And snow totals in the Sierra, something for the record books.
Never seen the paths up that high.
CBS News Bay Area presents First Alert. Wild weather, lasting impact.
Hello, and thank you for joining us. I'm CBS News Bay Area Chief Meteorologist Paul Heggen. Along with my colleagues Darren, Peck, and Jessica Burch, we're taking a deep dive into the active weather we saw this winter all across California, including how a series of late-season snowstorms turned the tide in the Sierra and how changes in the Pacific Ocean could give us a hint about what's to come. So let's get started with a look back at some of our wildest winter weather. The winter season brought strong storms to the Bay Area, including dangerous surf that once again pummeled the seaside town of Capitola in Santa Cruz County.
So the waves actually are bad, but what happens is the debris comes from the river, like lumber and trees, and then they just pushed over and through our buildings.
The huge waves flooding businesses and even prompting evacuation warnings. In Pacifica, large swells shut down the landmark pier for weeks, bringing people from all over the bay to see the show Mother Nature put on.
To see the waves and to hear them and the patterns, it's just beautiful.
In the North Bay, rising creeks and streams leave communities in knee-deep water, catching locals in Guerneville off guard.
It's just so fast. It's like no warning. Like there was no water on the ground from what I understood, and like 20 minutes later, all the water was on the ground.
For some people, it's disastrous. When you lose your car, when the water comes up to your trailer and, floods your whole thing, you don't have any money to do anything. Isn't that disastrous?
The wild weather producing a funnel cloud near Vacaville in Solano County as thunderstorms and lightning struck parts of the Bay Area. In San Francisco, heavy rain flooded streets and intersections.
Saw her out here doing this, and I saw the cars just with no regard coming by and splashing her, so I came over to help.
Residents come out with rakes in hand and work together to clear out storm drains.
And my shed flew there.
But it's not just the rain. Powerful gusts rip off roofs. And trees come crashing down on top of cars. A terrifying moment for a family driving on 19th Avenue in San Francisco.
And it's slow motion coming down, and then as soon as that tree falls on you, everything goes silent.
The fierce winds knocking out power for days, leaving homes in the dark and frustrating business owners.
All these ice creams of melt.
The Sierra was hit with a series of storms this winter, bringing heavy snow to the region and increasing the danger for avalanches. Now, back in January, a trip to the snow turned tragic when a 66-year-old man with ties to the Bay Area was killed after a major avalanche at Palisades Tahoe Ski Resort. 3 others were buried in the snow, but luckily they were rescued alive. At the time, this was a bit unusual because the area saw relatively little snow so far.
But after a slow start to the year, the last snow survey of the season found that the state snowpack was above average. It's at 113%. And that boost came following a March blizzard, which dropped more than 100 inches of snow in parts of California, ending the state's snow drought. Our Kelsey Thorid on how a change in climate could make snowstorms more intense.
It was a monster blizzard.
We're trying to get out, but I think we're stuck here tonight.
The storm slammed California with heavy snow, high winds, and treacherous whiteout conditions. But the aftermath, simply epic. In just 4 days, 6 to 10 feet of snowfall. Concern over California's snow drought evaporated.
We went from 0 to 100 pretty fast.
However, we have yet to dig ourselves out of the much bigger problem. It may appear hard to fathom, but this blockbuster blizzard with all of this snow may have links to our warming planet. Experts believe global warming may be supercharging some of our snowstorms while boosting the risk for a rapid snow melt.
Climate change is really affecting the underlying set of possibilities for what the weather system is capable of doing.
Andrew Jones is a climate scientist at the Lawrence Berkeley National Lab. His research involves hydroclimate extremes and snow dynamics in particular. This blizzard got his attention.
This was a very interesting storm.
A warming planet should mean less snow, but this was the Lollapalooza of snowstorms.
It really does highlight this conundrum that we see climate change kind of causing two counteracting forces at the same time.
With this blizzard, cold Arctic air made a beeline to California. On the way, it traveled over the warming Pacific Ocean, warming due in part to climate change. The higher temperatures in the ocean and the air allow the atmosphere to hold more water.
So the ocean temperatures are warm right now, and so this cold mass of air that moved down from the Bering Strait has picked up heat and picked up moisture as it was moving across the Pacific,
creating a warmer, wetter storm that was still below freezing. Jones is now keeping his eye on the snowpack, and with good reason. February was the 9th straight month in a row to be the warmest on record globally.
Because overall conditions are warmer, that snow might melt faster than usual.
Jones is hopeful for new strategies that aim to capture excess water and direct it underground. He also says it's not too late to slow down climate change.
We do have to be aware of the changes that are happening and start to prepare for them,
so we can weather any storm.
Well, there was a pretty counterintuitive moment in Kelsey's story. It came when she was talking to Dr. Jones from the Lawrence Berkeley Lab, and he said that one of the reasons the snow in the Sierra got a bigger assist this year was because the sea surface temperatures off our coast were warmer than average. And warmer than average sea surface temperatures were really a defining hallmark of this winter, primarily because this was an El Niño year. We've talked a lot about that already. There's the signature for El Niño. It was the warmer sea surface temperatures at the equator. But look at the rest of the globe. The entire world saw sea surface temperatures that were warmer than average. The entire globe, period, atmosphere and ocean together came in as the warmest year on record. If you put it into Fahrenheit terms, we were about 2.7 degrees above average for this year. And the science tells us that for every degree you warm the atmosphere, you've now increased its ability to hold more water vapor by 4%. That's what warmer and drier air does. It's kind of like a sponge. If you warm the atmosphere, you increase its ability to absorb more water vapor into it. So since we warmed the atmosphere this year by about 2.7 degrees, that equals about 10%. 10% more water vapor that the atmosphere could hold this year than it could before we started warming the atmosphere. And of course, if you look at those sea surface temperatures again, look at the North Pacific. That's where our storms are coming from. And all these storms had to move over Pacific Ocean, which was notably warmer than average. Warmer water was able to evaporate more into that atmosphere, which was readily available to take it up, and then turn it into snow at higher elevations. It's a very nuanced story when it comes to why we got the kind of snow that we did this year, because global warming is going to have an impact on snow in the Sierra in ways that might be a little more obvious, like where we're going to lose snow. First of all, look at this year from January 1st. This is all Tule fog filling the Central Valley. That is snow in the Sierra on January 1st, and we were way below average to start the year. And then we got the big storms going into March, and by the middle of March, that's what we looked like. And then by the time we got past the April 1st snow survey, we were sitting at 110% of average. By the way, one other April 1st snow survey, this one from 2015. And you can see what that one looked like, and it was way below average. That's the lowest snowpack on record. And it was just jarring to see the degree to which the Sierra can swing wildly from really big years to very low years. And that's what this graph tells you in one snapshot. This is from the Central Sierra Snow Lab. This goes back to 1950. Every bar gets a year. The tall gray bar shows you what the total snowfall was for that year. The purple bar shows you what it was at its deepest given point throughout that winter. So just look at the gray bars on here. See any patterns? You really don't. There is no clear-cut pattern here. Really big years, really low years, and then a lot of years that do kind of come in at average, which would be about 30 feet. By the way, this year is going to fill in right about at 30 feet because we were at 30 feet for snowfall this year. So we don't see a pattern here. But But we do see a very clear pattern in the Sierra in one other very important and nuanced way, and that's this image. So as a whole, the Sierra came in at about 100% of average for snowfall. And you do see that on this map. There's a scale over here that's showing you where you fell in the range of average. A lot of the blues and purples, which is the mid-elevations and the higher elevations of the Sierra, really did quite well. They came in fact, a little above average up there. And they had to make up for the fact that from about 4,000 feet and lower, it was well below average. And that is the pattern that stands out about this year. One number, 110% of average, which is where we were in the Sierra, only tells you a small part of the story. There are some other important details here. From 4,000 feet and below, we are losing snow in the Sierra, and that's one of the hallmarks of climate change.
Still ahead in our First Alert weather special, we take a look at the significant changes in the waters in the Pacific Ocean and how moderating ocean temperatures could impact the Bay Area. It's impossible to talk about our weather this winter, specifically the rainfall, without talking about the global perspective, especially the El Niño event that we have been tracking for basically the last 12 months since it was just in its beginning stages a year ago. And El Niño is that warm ocean water around the equator in the Pacific Ocean. The presence of that warm water disrupts the flow of the atmosphere over it, and that has a downstream effect on weather patterns around the world. But of course, we're focused on its disruption of weather patterns closer to the West Coast. So typically, when we're going into these El Niño events, we're looking for a strong signal towards wetter than normal conditions for Southern California and much of the southern U.S., with warm, relatively dry conditions in the Pacific Northwest. And the Bay Area is kind of in between. El Niño winters can go either way. What ended up happening is that we did see those wet conditions developing for Southern California. This is the map showing the percentage of average rainfall for the water year, which begins on October 1st through late March. And all of these green and blue shaded areas, specifically the Central Coast into Southern California, added up anywhere from 110 to 150+% of their normal rainfall during this water year. It's just a hallmark fingerprint of an El Niño event. Now, things are going to shift as we head towards next winter. It's never too early to look ahead, because what often happens is that an El Niño event is followed up the following winter by a La Niña event, its counterpart. And the way that develops is that the normal pattern reasserts itself, but it kind of over-asserts itself. Normal pattern is that the trade winds blow warm ocean water towards the western Pacific. But what happens during a La Niña year is that those trade winds are even stronger than usual, and they push so much water into the western Pacific that you get upwelling. The cold water rising up from underneath to replace that displaced warm water. Now we have this cold pool in the eastern Pacific off the coast of South America, essentially an intensification of normal conditions, but that also can have a downstream effect, just like El Niño does. Its counterpart, La Niña, can have those disruptive effects around the entire world. And it's a good chance that this La Niña event is going to develop. We're still in the waning stages of the current El Niño, but it's a good chance, over 80%, that we are going to be into La Niña conditions by the time next fall and next winter roll around. So what are those La Niña conditions? It is basically the normal weather patterns we get across the country, but just emphasized a bit more. It's typically warm and dry in the southern tier states, including in the desert Southwest. The wetter than normal conditions in the Pacific Northwest tend to be emphasized even more as the jet streams kind of merge to emphasize that pattern. Colder than normal conditions in the upper Midwest. And for the Bay Area, once again, we find ourselves in between. There are some La Niña years that yield normal rainfall, some that are drier than normal, some that are wetter than normal. So we want to get into the details of how strong is that La Niña event going to be. This El Niño event has been the 5th strongest on record, dating back to the winter of 1949-1950. It doesn't look like the corresponding La Niña event that develops is going to be as strong. Most of the forecast model data in each one of these lines is a separate forecast model, kind of levels things off with the ocean water in the Pacific being about 1 degree Celsius below its average temperature. You need to get up to a degree and a half to 2 degrees below average before it would be a strong event. So I went back and looked at some of the data, trying to find some correspondences between the strength of a La Niña event, or just the existence of a La Niña event, and rainfall amounts in the Bay Area. So there have been 18 La Niña winters since that winter of 1949-1950. That's how far back we have that good, reliable ocean temperature data to let us categorize whether it's an El Niño or a La Niña. And of those 18, 7 were drier than average for the Bay Area. 8 were near average. Only 3 were wetter than average. But again, that looks at all the La Niña winters, not accounting for whether they were strong or weak or somewhere in between. If you just look at the moderate to weak El Niño events, there have been 9 of those, and 4 of them were drier than average. 5 were near average in terms of total rainfall for the Bay Area. 0 were wetter than average around the Bay Area. Now keep in mind, 9 events is the definition of a small sample size, so we can't draw any firm conclusions from the presence of 0 of those wetter than average winters, but it is a sign that kind of nudges us in the direction of thinking that maybe our 2-winter stretch of wet weather for the Bay Area might be coming to an end as we round the corner into the following winter, but it's still a long way down the line at this point.
Thanks, Paul. Now coming up, several atmospheric rivers caused days of heavy rain in California. What we know about these common phenomenons and its impacts.
Plus, why this winter's rainfall is anything but normal. This winter gave us close to average rainfall in Northern California, and believe it or not, that's kind of unusual.
Wilson Walker explains why having this average winter is anything but normal.
Like Shasta and Oroville are well above their historical average, but they're not full. They could be full, but they can't be full because you have to leave some space to manage floods.
Watching the reserves stack up across California, water researcher Jeffrey Mount and the winter of 2023-2024 is quickly becoming a remarkable one if you take the wide-angle view.
Precipitation back to 1950, and this is through 2022. And one of the really striking things you see about the 21st century, post-2000, is how many dry years, just a lot of dry years.
This is the 2014. Yeah, this is what we do.
I don't know how long we can go with this.
The drought that stretched from 2012 to 2016 was considered the worst on record. It ended with the single wettest year on record in Northern California in 2017, and almost just as quickly, the state descended right back into more years of drought.
The real fear is what's next year bring. You know, what happens next year.
The so-called average year, like we're having now, is becoming rarer and rarer. And this is a climate change signature. And that is our wet years are becoming wetter and our dry years are becoming drier. That's the signature that's really starting to show up.
And this average winter we're enjoying gets even more notable when you consider just how rare it is becoming to have a wet year like last year, followed by anything other than a dry one.
You know, we're almost a quarter done with the 21st century, and we've only had 2 pairs of years where we've had wet back-to-back years. This one and back in 2004 and 2005.
So California, a state built on the whims of variable weather, is only seeing more of it as extremes become the norm and average becomes increasingly uncommon.
But what's happening is that variability seems to be increasing, that the dries are getting drier and the wets are getting wetter. And that's our huge challenge for managing in the future.
California experienced another active season of atmospheric rivers into the beginning of the year. And as that season comes to an end, it's important to recap all of the impacts those storms have left us. Now, the strongest atmospheric river to impact California occurred on February 4th, and it brought heavy rain and winds to Southern California. Now, Los Angeles, for example, they received 8.5 inches of rain from that exact storm, which was the second wettest 3-day stretch on record. And snowfall up into the Sierra, it increased the year-to-date snowpack from 10 to 20%. That's just from that storm alone. Now, this atmospheric river is proof that just a few strong storms over California can really make or break a water year. Now, there were 13 more atmospheric river events that impacted our west coast this year compared to last year. But as we break apart the tracks from this year's storms, we noticed that there were more consistent and stronger storms that actually went up into the Pacific Northwest compared to our California coastline. Last year, there was a more dominant southerly storm track that really helped the state get out of drought conditions, but it still left behind devastating impacts across our coastal regions. So with over 50 atmospheric rivers impacting our whole west coast this season, we should take a look at where our rainfall versus average is currently at. Taking a look behind me, areas like Santa Rosa down into San Francisco, over 100% of average, which is amazing to note. But I want to head over to our virtual reality map and show you a couple more areas. Napa, for example, only at 80% so far, 90 into Oakland, and we're 69% of average over into Concord for our rainfall season to this date. Now, this is going to help a lot when it comes to our Bay Area reservoirs, this rainfall total, especially as we head into our drier months. So let's start off by taking a look at our local reservoir storage to date. Close to 100%, just up close to San Pablo, over 100% near Berryessa. And as we stretch a little bit wider into our state, we see improving numbers all throughout the Sierra region as well. Now, this is good news for groves and wine country, and it's a promising sign that the aquifer system, like the one in the Sacramento Valley, will have healthy surface water basins. Now, as we turn to the drought monitor and compare it to last year at this time, we're no longer in drought conditions anywhere in our state. This is huge news, and this is amazing news for us here in the Bay, because in California, we need all the water we can get. So taking a look at last year compared to this year, a lot of improvement. We're no longer in a severe drought. We're completely out of that. We're just seeing a little bit of dry conditions in tips of Southern California. But this is big news for us here in the state and here in the Bay.
Coming up, a popular destination for Bay Area families is still recovering from last year's winter storms. We take a look at how far the park has come along.
We've had plenty of storms this year, but some areas are still recovering from the relentless rain that we saw last winter.
San Jose's Alum Rock Park was hit hard by major storms earlier that last year. It's triggered landslides and undercut the only road into that park.
We know how much this park means to our community, and we love seeing visitors out here use the park.
The city has been figuring out how to repair the road and how to pay for it. The current estimate is as much as $19 million for a massive retaining wall that would prevent further erosion.
For now, they've reopened one lane of traffic and installed a temporary stoplight.
Thank you for joining us for our winter weather special. Throughout the rest of the year, our entire First Alert team will be tracking the latest conditions to keep you one step ahead of whatever Mother Nature throws our way. And as always, you can stay updated on our changing weather on CBS News Bay Area.